Hello viewers, in this video I'm going to demonstrate and discuss about Suse HAE cluster overview, important components, and also I will going to introduce the graphical tools which we have for Suse HAE cluster. And those two graphical tools are, the first one is Hawk and the next one is CRM Pacemaker GUI. Okay, so I'm going to go through, and before that I wanted to talk about and history and also talk about a little overview and important components. So I have prepared one slide here. Sorry, okay, I have prepared one slides, and in this slide, the first slide, it says about the history and overview. Okay, so Suse HAE cluster, which is introduced first in Suse Linux Enterprise Server 9, and it was called as Heartbeat. So, and it was also support only 2 nodes, so it was an initial state for initial state to introduce Suse HAE cluster, and it didn't have features to support more than 2 nodes, right? And later it is introduced in /10, and which was called Heartbeat plus CRM. Okay, and it is also a call Heartbeat version 2 because it's a revised version of Heartbeat, right? So it was called as Heartbeat version 2, and also it was called as Heartbeat plus CRM. So it supports more than 2 nodes. So this means what are the issues we had in Suse Linux 9, it has overcome. So it was support more than 2 nodes, and in CRM, which is, if I say the acronym is for CRM is Cluster Resource Manager. Okay, so I will talk about a little what is this CRM and what it is, what CRM role is about. Okay, so all cluster metadata stores in XML database. So what are the configuration we do and changes we do in cluster configuration. Okay, so all those settings will stored in an XML database, okay, which is called CIB, cluster information base. So it is introduced here in /10, and yeah, it stores the metadata database. This is what it says. So I will talk about what are CRM and what is CIB later in this slide. And later it was introduced in Suse Linux 11, which is called OpenAIS with Pacemaker. Okay, so it is same as Heartbeat version 2, which is introduced in /10, but it support more than 32 nodes. So here we have now more features, and we have more visibility, so we can add up to 32 nodes, right? And it is also use the same XML format, and it saves in CIB database, right? And use cluster stack OpenAIS for cluster communication, messaging, and infrastructure service. So this OpenAIS service, which is use the layer messaging and infrastructure service, there are different 3 types of layer we have in cluster. This is HAE cluster. I'm going to talk about those later in this slide, what are those layers are and what are their role. Okay, so next slide is about cluster terminology. It is basic. I'm saying it's most widely used cluster types which we use in real-time scenario is cluster active one type, and another type is cluster active passive. Okay, so in active in general, if I say what is active cluster, so I will say for example, in your cluster you are running 2 node, right? And in this 2 node you are running resources, which is a part of cluster. So what are the resources you are running in that cluster? If those resources are running in single node, right, then it is active passive cluster. And if you are running a cluster multiple nodes and providing the services simultaneously, it provides the service simultaneously, right, those cluster type we will call as active. Okay, so In HAE cluster, we have one resource type is called cloned resource. So we use cloned resource to provide active cluster architect. Okay, so if you are using activity cluster, we're going to use a clone resources, which is a type of one resource. Okay, so this is what active cluster in a basic explanation, if I say. And the other one is active passive. So active passive is nothing but out of two node we're running resources, and those resources are primarily running on one node at one single time, right? So you, for example, if you're running two node 1 and node 2, and the resources which you are running, everything you are running in node 1, and the other node 2 is acting as standby or failover node. So whenever a node 1 is down or failed, it will move all the resources to node 2. So it is also vice versa. For example, if you're running resources in node 2, and if it is failed, it will move all the resources in node 1. So this is how the setup is for active passive. Okay, so next slide, it talk about the architecture. So we need to understand a basic about the architecture, how it communicates and how it works background, and we need to understand the components of cluster resource, what are running in background, right? So those are some important components we have it, and the layers in this HA cluster. Okay, so let me talk about the first resource, which is in bottom, which is called messaging infrastructure layer. This layer is basically used for to communicate the nodes, and it will send for messaging purpose. It will use for messaging purpose. So it says the first node to other node simply I'm alive, and same vice versa. This node also says to other node that I'm alive. So in that case, the cluster is functional, and it is for example, if one node is down and it is unable to send the message to other node saying I'm alive, if it is unable to, for some reason, if the node is down, then what will happen, right? The other node, it will fence the node which is down. So in this case, this messaging infrastructure layer, which simply communicates to other node and saying I'm alive, it is it act as a very important role, right? So this is what the messaging infrastructure layer in basic. And the next one is called as resource allocation layer. So in resource allocation layer, there are quite a few components we have it, and the first component is cluster resource manager, which is in short we call CRM, and it is also said here designated coordinator. And here we have one more component called LRM, and the other one is PE, and this one is CIB, which is cluster information base, and the format is in XML. So how they communicate when there is a request. For example, I just wanted to move a resource group from one node to another, right? So I just ran a command CRM resource move resource name and the node name. So when I do initiate that command, how it is communicate. So cluster resource management who decide, and also the designated coordinator. Designated coordinator act a major role when comes to any request, right? It communicates with P engine. It also communicates to local resource manager, and also it will update the what are the changes or what are the requests we have sent the signal that has populated to XML file here. So anyway, I'm going to discuss a little about what are this role about, and what they do actually. So I will discuss about in next or later slides. Okay, so the third role is the resource layer. Here we can see we have only one component called resource agent. Okay, so this is how the architecture look like. Okay, so you need to have a basic idea how it works background when it comes to troubleshooting, otherwise it will be very difficult to find the problem. Okay, so next slide talk about the layers which I said. Okay, so the first layer is messaging and infrastructure layer. Okay, it is also called as CoroSync or OpenAIS layer. Okay, this layer contains components that send out the messaging containing MLF signal and as well the other information. So like I said, it's a communication to nodes running in the cluster saying that I am alive, right? So this is what it does, and some other important roles also it does by this messaging layer. So next layer is resource layer. So the highest layer is the resource layer. Okay, so why it calls highest layer here? Because of this slide, if you see, this layer resides in this top, right? So that's why it says as highest layer in the resource layer. And the resource layer includes one or more resource agents. Resource agents are programs, usually shell script, and that have been written to start, stop, and monitor a certain kind of services. Okay, and resource agents are only called by the LRM, right? So now let me understand. Let me try to explain the first one. The resource layer includes one or more resource agent. Why it calls like this, one or more? But in this slide it says only one resource agent, right? By why it is says one or more? Because if I go back to my putty node putty and try to run this command crm_mon to check the status for the server and the cluster, it says there is one resource I'm running one resource agent Stoneit, and in this resource group I'm using another resource agent which is called OCF. So it can be more than one. So this is what it says, and it is also said it is programmed in shell script. So here there is a location if you wanted to check. Sorry, user lib OCF. I'm going to check under OCF and resource D and heartbeat and ls. Now these are the scripts which is available under OCF resource agent, and those are in shell script format, which is said, right? So now, for example, I wanted to use LVM or IP floating IP address. So LVM, if I wanted to use, just to check, see here it says shell script text. So it is all written in shell script format. So it is not like you cannot use your own customized script. You can also use your own customized script. Only thing is that should be in this format, and the script which you have write, that should be have the all functions start stop functions it should be. And once you have that, so you can place your script under this location and you can use them, right? Okay, so this is what it says. Now yeah, so resource agents are called only by the LRM. So what does this mean? So here in this slide, if you go and see, this resource agent only talks to LRM. So it doesn't talks to anything or other components, policy engine or cluster resource manager. It does not communicate. It only communicate with the local resource manager. Whatever the local resource manager command or said to do, it will do, right? So this is what it says. And the next thing is about the resource allocation layer. So in this resource allocation layer, we have quite a few components, and the first one is CRM, right? So what is CRM? every action taken in the resource allocation layer passes through the cluster resource manager. So it is it is a major components, and it act as a it act a very important role, because what are the action we said to do to cluster, it should go through the resource cluster resource manager, right? So that is why it is very important. So next thing is, if other components of the resource allocation layer or components which are in higher layer need to communicate, they do so through the local CRM, or every node the CRM maintains on every node the CRM maintains cluster information base, right? So yeah, so CRM acting a very important role. And what are the information or what are the actions we need to perform, that has to go through CRM, and CRM will decide where to write. It will write in CIV XML format, right? And what to write, the CRM will have this information. Okay, so next is LRM, resources manager, local resource manager, responsible for performing operation on resources. So it is acting a role to command resource agent. So it acts a primary role of what are the commands we pass to do in the cluster. LRM act a primary role to tell resource agent do this or do that. So here in the slide it says here, so this act a primary role to tell resource agent stop this service, start this service. So the only communication is local resource manager. Okay, so this is LRM, and also the resource agent, like I said, yeah, we can have a different types of resource agent. The first one is OCF, which is stand for Open Cluster Framework. We also have LSB, Linux Standard Base, and we also have heartbeat resource agent. Here it says 3, but we have more. I will show you in Pacemaker GUI or in Hawk. So those are the different types of resource agent we have, which we can use. And the policy engine, right? So what is the job, or what is the role of policy engine? So policy engine computes the action that needs to be taken to implement policy changes in the CIV. So the PE also produce a transition graph containing a list of resources, action and dependencies to achieve the next cluster state. And one thing we have to keep in mind, that policy engine only runs on designated coordinator. So it doesn't run in the other node. So it runs only on the designated coordinator, irrespective of how many nodes you are running. Wherever your node is running or acting as a designated coordinator, policy engine runs on that system. Okay, so next slide is talk about resource allocation layer. Yeah, so what is what is cluster information base? So CIB in short we call. So cluster information base is an in-memory XML representation of entire cluster configuration and current status. So what are the cluster configuration we have it, what are the resources, group, clone, whatever you have created, all this information is saved in CIV, and that is in XML format. Okay, so the next is designated coordinator. So what is designated coordinator and it is role? One CRM in the cluster is elected as DC. So for example, when you have a 2-node cluster and you brought those 2-node cluster up simultaneously, right, in one time, And once the system comes up, and wherever the cluster service resource, the OpenAIS service, wherever you start the service first, CRM will CRM will met that node as DC, because here CRM is deciding which node is going to be a DC, right? So wherever you will start your OpenAIS service first, it will met that method node as designated coordinator. And there are quite a few roles which is done by the DC. So the DC is the only entity in the cluster that can decide that a cluster wide changes needs to be performed, and such as fencing a node or moving a resource around. And the DC is also the DC is also the node where the master copy of CIV is kept. Okay, so and also other nodes get their configuration and resource allocation information from the current DC. Okay, so these are the roles which is done by the designated coordinator, right? Okay, so next slide. So in this slide it talks about the resource agent now. Okay, so where those resource agent located, in this location if you go you would be able to see. And what are the types? The first type is OCF, and the other type is LSB, and this location is /etc init.d. in this location it would be. And what are the roles, and what are the script types, and what those script does normally. So that does stop, start, restart, post, reload, and status. So this is a type of LSB script. And Stoneit, this is a location for Stoneit search agent. Okay, so these are the basic and more important things in Suse HAE cluster, and we need to know about them, at least a basic, otherwise you would confuse and or you would not know how the cluster is functioning. Okay, so next thing is resource constraint. Before going to discuss this resource constraint, I'm going to go to my vSphere client, okay, and talk about basic about resources which we have, and what are the resource type and resource constraint. Those we are going to discuss. So let me bring Hawk first. So it is already running in node 1, also node 2 it is also running. If you wanted to use node 2 you can do that. I'll go to my Chrome and I will going to log in. Okay, proceed. It is loading. Okay, it didn't ask the username and password because I logged in earlier, so, and I saved and not to ask password, so that's why it did not ask me for login, and simply give me this screen here. Okay, so the first one, if you see here, it says about summary. So in summary it says the Stoneit is enable or not. I already had a video, and I have it in my channel, what is Stoneit and how to configure. Okay, so this is a Stoneit, and now quorum policy is ignore. Whenever you are going to use 2-node cluster, ignore is the best option to use. And symmetric cluster and the resource stickiness I'm going to discuss. And Here you can also see basic details about the nodes configured, and also you can see basic details about the resource running under this node. Okay, so next here we have something for reporting. So you wanted to uh, grab a report, or you wanted to see, for example, for some reason if your system is not working, your cluster is not working, and you raise a call with novel, and you wanted to troubleshoot further what is the problem in the cluster. So you wanted to run uh, logs, you wanted to capture the logs for the cluster, which will have all the information. Basically for OS, we run support config, and for Red Hat based system we use I literally, it has literally come out from my mind since I'm not using Red Hat for quite some time. Okay, so not a problem. Okay, for Suse we use support config command. So for clustering, what we have? So for clustering we have this one. So this is a GUI based HP report, which is high availability report we can capture, and we can give it to vendor, right? And we can analyze the logs and check what are the issues in this logs we can find out. And also you can do this through command line. HP report is the command. Okay, and there are options if you wanted to see how to run that. So you probably need to use those options, or you probably need to go ban SP report, and bottom of the file probably some example we would have here. Yeah, so this is how you can run command line, right? So, and we have one more reporting, I believe, CRM report. Yeah, so this is another types of uh, reporting which we can do. We can capture the logs through this command. You can run this and you can capture the logs for cluster. So example, for you can see here how to run them: CRM report, file name, and the time name, right? So you can capture the log like this via command line. Okay, so this is what is regarding reporting, and the next one is sorry. So here comes the default settings about the resource which you are going to use. For example, if you are going to use this cluster node as an NFS server, so you can directly click on NFS server. Next, give the NFS server name NFS minus NFS, an example is given here. Next, and the resource ID you have to specify, and if you have any file system ID you can specify, and the mount point, and the options if you wanted to use something you can specify, and also the mount option. Let me just go default like this, and yeah, so again it is asking for NFS server NFS export. We have 5 out of 3. Next, it is not going because this mount point is not available. When I specify this mount point and say next, it is trying to look for this mount point, whether this mount point is available in the system or not. Since this mount point is not available, it is keep on trying to find this mount point, and eventually it is going to fail. So let me cancel it and let me go back to here. Yeah, so this is how you have to give, you have to select and you have to provide all the correct information, otherwise it will not going to create. Likewise, cluster driver, LVM, db2 if you are using, and other options we have handy here. Default it comes here with the packages which we have installed. And the next one is about the cluster configuration, the CRM configuration, the cluster wide configuration which we do. Okay, so this changes is not for the resource individually or for the resource group. This is for the cluster wide configuration. What are the nodes you are running on the cluster, it will implement to all the nodes. So no quorum policy in case of 2 nodes, it is advisable to use ignore placement strategy. It is also advisable to use balanced, and I will probably show you what are those options in the slide later. What is default used for utilization, minimal, and balance. And here freeze, suicide, and stop options are. But it is recommended when you are using a 2-node cluster, you always use ignore, and placement strategy you select as balance. And next one is turning timeout. So what are timeouts you wanted to set? Default it is 90 seconds. If you wanted to use more or less, you can use that. And there are some additional information we have it. If you wanted to use if you wanted to put that cluster in maintenance mode, for example 1, this maintenance mode, and you can enable this and save it, it will make the change. So in which scenario we use maintenance mode? Okay, so I'll tell you. So now I have one more node called node 2, and let me log into that node as well. This is IP for node 2. Okay, so here if I do CRM configure so and check for the configuration file, I do not see, this is the cluster wide option, I do not see maintenance mode, right? So I will going to update the maintenance mode here, but before that I will tell you why we use the maintenance mode. So whenever you are doing a changes in the cluster, right, if you are going to do some changes in the cluster and there needs to be cluster wide changes, you probably wanted to make that node in maintenance mode, because if you do not do that and if you just try to make change online, it will probably, or it is most likely going to reboot or fence the system. So in order to avoid, we always keep the cluster state in maintenance mode, and once we keep it in maintenance mode, we'll do the changes, and once we are done with the changes, we will revert back, right? So here is the command crm configure property maintenance minus mod equal to true, Okay, if I let me check whether okay, so I still did not apply the change. I just selected here, but I did not make the change here. If I do apply change, then only it will going to make the changes. Okay, but I did not do that. So here in command line you can do like this. So for example, now if I run crm underscore mon -1, it says it is running and all started state, right, and it is managing by the cluster. This LVM, this file system, is managing by the cluster. So I want to keep this cluster in maintenance mode, so that if I made any changes, it will not cause any issues. So I will run this command, crm configure property maintenance mode equal to true. So if I do this, that means I kept this server in maintenance mode. And now if I run crm underscore mon r1, you see here it says unmanaged. So this means the resources which we are running in this cluster is now not managed by the cluster. So it is not part of cluster now. So I can go back and I can do the configuration changes, whatever I would like to do, like crm configure edit, and inside this I'm going to change this timeout setting from 15 to 20 and save it. So once I saved it, I made the change, and that looks good, and I will make the cluster state back to normal managed state. So for that I need to run this command, and once I run this, and you can see it is again managing by a cluster, and it is all started state. So this is the basic and main reason we use this maintenance mode. And also earlier when I did crm configure show, this command, you cannot see that maintenance mode in cluster wide section, right? So now if I do a crm configure show again, I can see one line has been added here, maintenance mode equal to false. So this is the cluster wide changes. If you wanted to add additional, you can add it, right? So this is how we can do command line. And for to make the change from Hawk, you just have to select like this, maintenance mode, check this option, and apply the change. So if I make this changes, that maintenance mode will become equal to false, and I will show you in command line here, and it will show here as a unmanaged state. So now if I do crm underscore mode, it will show unmanaged here. So it is saying unmanaged, and also crm configure show, here you can see it is true, right? So I'll make it back to false, or I'll probably go to Hawk and I'll do these changes here. So uncheck, apply changes. It is loading, and it is done. So your changes have been saved. So if I go back now again here, and now if I do crm underscore mon, it is gone, and also crm configure so it has become false. Perfect. So this is how it is used, and this is how we have to make the changes. There are multiple options we have it. If you want to use them, you can use, but what are the basic and important settings we need to do, you just have to use them, not all of them. So, and here comes the resource default part. In this part you can see migration threshold 3. Okay, so what is migration threshold? I'm going to discuss migration threshold later, and I'm also going to discuss what is resource stickiness. Okay, and also operation default timeout is this one, and what are the other options we have it here. Okay, let me go to access control list. You can create users which you can give access or you can give rights, whether this user is going to have a write access for this cluster or read access, and or whether this user is going to have only monitoring access for this cluster. So you can create users and their roles under this section. And the next option is resources. So in this resources you can have you can see data fs data fs and stored underscore sbd. So there are different types of resource we have it. The first one is primitive, second one is template, third one is group, clone, and master and slave. So the first resource is primitive. So this is a mandatory resource which we have to create whatever you are going to use, or whenever you are going to create any resource. This is the basic and mandatory resource type which we have to use. So we have multiple resources, and those resources can be anything like fs, and class is ocf, provided is heartbeat, provider is heartbeat, and here is a type. So these are the types we have it. So I'm going to use file system. This is the type I'm going to use, and what are the device I need to use. What are the device you have it, you have to specify like this /dev vgname and lvname, directory where you are going to mount. What is the fs type, is it whether it is ext3 or ext2, and the other options, whether it is going to start when you when you say create resource, whether it is going to start state or it is going to stop. Those actions you can specify here. And other monitorings, like if the file system is stopped for 40 seconds, then what are the next action it will going to do, whether it will going to try to restart that file system, or it will going to stop it, or it will going to ignore. So those are the actions we have it here. Okay, so we can use monitor, and we can specify those options, start, stop, and other options. And meta attributes, here we can specify whether the file system which I'm specifying here in cluster primitive, whether that is going to be a part of cluster or not. So if it is a part of cluster or managed by cluster, then I will say is managed, and I will check this option. That means the file system is a part of cluster, and I will create resources. Okay, so for creating a resource group, clone, and other stuff, what are the resource options we have it, those I would have a separate video. Okay, not to confuse much in one single video, that's why I'm not going to show you now how to create them. For that I will going to have a different session where I will show you command line how to create, and also I will show you from graphical one how to create them. Okay, let me go back. Yes, I'm not going to make this change, so I'll say yes here. it is a bit slow and still trying to load. Okay, something is not good, it seems. Let me click in here. Okay, so I come into resources section, and in this section I can see there are three primitives I have created here, and out of that there are two primitives. One is for fs data fs and another one is fs data fs. Okay, so for example, now when you create a resource group, and in this resource group what you need for file system, in order to create a file system you need LVM, right? So I will create a primitive for LVM also, and I will create a primitive for file system, and this two primitive I will put that in group, right? Because to run that file system I need file system and also I need LVM. So I have created these two primitive here and I have added them in a group. So if I expand this and see the group, there is a group called GRP-FS. So in this group I have these two primitive. So command line I will show you here. If I run this command, here you can see the resource group name is GRPFS, and the first resource is or the first primitive is LVM, and next primitive is file system. So I have added them on this resource group, and this one is currently running on node 2. If I go back here and do a DMF and H, I can see this file system is started in node 2. So this is what the resource group. Okay, so and we have also clone. Like I said earlier, if we wanted to use an active cluster and then those needs to be run simultaneously, we will create clone, right? And also we have one resource type is called template. So for example, this is the default, like 10 GB of file system we need for this system every time. So every time you go and create a new primitive, instead we can create a template with default setting of the primitive name and the size and other options. So those default settings would be there in the template. So whenever next time we are going to use or you create the file system, we're going to use that template, right? And we simply use the template and say create. So once I do that, it will create the template and we will have that file system. So it will save a lot of time where we are going to create manually one by one all this file system primitive and LVM primitives. So if you have template, you can select that and you can just say create. So that's why we use template. And the next setting is about the constraint. Okay, so there are basically three type of constraint. The first one is location, collocation, and order. So I'm going to discuss about this in my next video, what are those constraint about and what are those constraint role is. Okay, so for now I think for this video this is it. I'm going to discuss more about the other important component we have in a cluster, and I will also go through Pacemaker GUI in my next video. Okay, so thank you so much for watching this video. Have a good day.